Today's webinar. We will just give it a couple of minutes while people join, but yeah, we will get started very soon. For those that just while we wait for a couple of minutes, if anyone does want to follow along today, it can be a really good way to learn. So if you are interested, you can, if you're on YouTube, follow the link in the comments to just log in for a trial account. Or if you're on our website, if you follow the login button in the top right, you'll then be prompted where you can say you don't have an account and sign up for one. But yeah, if you just want to watch me as well, still a great way to learn. And for those that are just joining right now, probably give it one more minute while people join, and then yeah, we'll get started. All right, well, hello everyone, and welcome to today's webinar. My name is Jonathan Mosdell. I'm a mechanical engineer and one of the co-founders here. Within this 1 hour webinar, we're going to be going from a blank project all the way through to a fully calculated project where we've got all of our heat loss calculations and the whole system is sized. And pretty similar to what we can see on the screen here is what we'll get to. And at the end, we'll look at some of the exports that you can then provide your client, such as a PDF to give a good visual of the system. You'll have a bill of materials to help with the estimating, and there's full transparency for all the calculations as well with the calculation report. So I was just saying that just watching me today is a great way to learn, especially because you can replay these webinars. But if anyone does want to follow along, if you're on YouTube, we have a link to the trial sign up page that you can start a free trial with and use the software. Or if you're watching on our website, if you follow the login button in the top right, that will take you to a page where you can say you don't have an account and sign up. So following along is the best way to learn, but you probably will struggle to keep up, so completely up to you. And yeah, you can ask questions throughout. So if it's on YouTube, I will see them as they come through. And if it's heating related, I'll answer them straight away or as soon as I can. For just general H2X ones, I'll answer at the end. And for any that come through on the email, I'll probably just see them at the end. But yeah, all right, let's get started. So we're going to start from the home page here once you've logged into H2X. For anyone following along, just if it's your first time using it, you might end up on a different page with the first time you use it, it shows you something else. But you can just keep pressing home or come to the home and you'll see this. And it's probably better to follow from this point. All right, so the first thing you want to do is you want to click on New Project. And this will then ask you for the project name. So let's go with webinar for today. And just want to make sure you've got the UK locale ticked, because that's going to have all the right settings for you. For example, if you pick the US one, it will be in gallons and inches. So yeah, just make sure you pick the right one. Then because we're doing heating today, none of this matters, so I'm going to skip over it. Most of this doesn't matter today, but the heating one does, because we'll be doing some heating system sizing. So you can drop that down, click heating, and this is where you choose materials that you want to design to and a maximum velocity. So these are the defaults, but if you want to use a different material, you can feel free to select it. And 1 meter per second is the industry default, but if you want to design to a different one, feel free to change that too. And this last page doesn't relate to heating very much at all, so you can just click create project. It might ask you to pick some manufacturers. I don't think they're going to be heating related, so it doesn't really matter. The main thing is you want to get to this page that I'm currently on. Alright, so the first thing we're going to do is we're going to do the heat loss calculations. So there was a webinar earlier in the week where we did heat loss. I didn't upload a floor plan, so today I will. So the first thing you want to do is click upload floor plan here and choose the PDF. So I'll go with this one. It takes a couple seconds to come in. It will be locked so you don't accidentally move things, so you just want to unlock it. And the main thing to do here is you want to check the scale's correct. Obviously if the scale's wrong, all the calculations are wrong, so it usually gets it right. So we've got 1 to 50 at A1 on the title block, and that's what it's picked up. If it's ever different, just choose it from the drop down menu. And if there is no scale, you can just measure 2 known points on the PDF. And then yeah, if you want to just tidy it up a bit, you can crop it like this. If you're doing multiple levels, you will need to align the PDFs, but I won't get into that today. But we do have plenty of videos on YouTube to help with that. Alright, so now we're going to do the heat loss. And just like we did earlier in the week, for anyone that was there, or for people that weren't there as well, whether you're uploading a PDF or not, it is the exact same process for doing your heat loss calculations. So because I can see the rooms here, I'm just going to trace over them. If you didn't have a PDF and you've just been to a building doing a survey and got the measurements, you just draw it exactly the same way, but yeah, you just kind of push the rooms together rather than tracing over it. So you have the measurements as you're drawing the rooms, it will tell you how long they are, and yeah, I suppose it'll make a bit more sense when we start doing it. But the first thing we want to do before we start drawing is just check the settings. So we'll click on heat loss here at the top, come into settings. Alright, so we'll just go through the first 2 tabs. The second 2 are for cooling loads. So the software will do chilled water systems too, but we won't focus on that today. So just to go through these, you want to set your external winter temperature. So you can enter any number you want, or we have some defaults here. And all the defaults come from either MCS or CIBSE. They both use mostly the same ones anyway. So yeah, we have them as defaults, but almost everything is customizable. So you can create H2X how you want it and choose from anything. Set a different temperature for the ground. You can add a thermal bridging coefficient. So this is where you have conductive areas, whether it's the material or like joints in the building, where there's going to be extra heat loss. So you add this on as a percentage. So it's default to 5%. Feel free to change that. And also if there's anything else in your design, like maybe you're a bit worried that your survey is a bit inaccurate or something, you want to be a bit more conservative, this is a great place to just add an extra 10% or whatever you think's reasonable on. So if you ever just want to add percentages on, even though it's a thermal bridging coefficient, it's just a great place to put it. For the heating degree days, this can be found outside of the software. It's different for every location, but it will inform the energy calculations that we'll see at the end. We'll ignore heat gain today. You want to choose how old the building is. So the older the building, the more air changes per hour, which means you're heating that air up multiple times per hour. So very important to form part of the calculations, and just important to choose it correctly. So again, MCS and CIBSE provide this. So we've got post 2000. Then we have a range of materials that you can choose from, and you can create your own. So if we come back up to the top here, let's say we want to make a new window called, just call it window 5. That is a window. And the thermal conductivity, just put any number you want in, but say that's a 3. When we come down to window now, that will appear here and you can choose it. And you can create template projects. So you can come in and build in all of your database essentially into a template project. And the same goes for like radiators, your budget for the bill of materials, and just everything for the settings really. So you can just do it once. Then you can choose default colors, so you can have external walls to look different if you want them to. And you can choose default dimensions. So good example is a window. If you know every window is 1.2, you can choose this here. You don't have to change it every time then when you add one. All right, and then the only other thing to add is for the roof and the rooms. So again, for the rooms, we've got a load of MCS SIBSI defaults, but you can create your own. So let's say we want to make, I'll just go with a hospital example. Can't think of any others, but give it a name. Then you can choose the temperature. So if it's 19 degrees and 1 air change per hour, you can put this in. And like we saw before, having different numbers for the different ones, it will look this up. So you can create a database of all your rooms as well. And then the last thing in the settings, nothing to really change here, but just to show you, we have a range of roofs available as well as a flat roof. So really for vaulted ceilings, you can design a range of roofs. It will look at the heat loss from it, and it will look at the air changes, and yeah, all be added onto your design so it's accurate. Cool, so that's the settings. It normally only takes a minute for you to go through that. I was just explaining it, so not like you have to do that every time. But the fun bit now is drawing. So it's a really visual way to do all your calculations. So yeah, let's get started. So I'm going to start with the utility here. So choose the room, find the one utility. And we're just going to click every time we want to put a bend in the room. So just like this. And as soon as you've done that, slow down a little bit. You can right click or double left click to finish completing a room, and straight away it'll start giving you the information. And if you click on it, you can override all the properties here. So for example, if you don't want to follow the defaults for temperatures or air changes or whatever it is, materials, you can change all that here. And although it shows a number now, because we've only drawn this room, it does see everything as an outside wall. So it's very cold on the outside, which isn't the case. So we'll see now as we start adding more rooms. Like if we add the study here, we'll see the heat loss from the utility decrease, because one wall where it thought it was minus 2.2 is now 21. So I can't remember what that was, but it would have gone down slightly. And internal walls are recognized and look different. All right, let's do the kitchen now. So to go a bit slower, left click when you want to start the room, and then every time you want to put a bend in it, do the left click too. Let's go here. Oops, sorry, I made a mistake there. It is easier sometimes if it's not working because you've clicked in the wrong place, just delete it and start again because it is so fast to do it. So sorry, I just stopped at the wrong point. So I want to go all the way to the wall. So I was just going to point out, you can hopefully see the dimension that's in the middle of the doorway now. So it's currently around 3 and going down to 2. That is what you'll be using if you didn't have a PDF. Like luckily I can just trace what I have here. But again, if you've been to site and done a survey and you didn't have that, it's really easy just to use those dimensions. Alright, got the toilet. And now as we've drawn most of the room, it's getting easier and easier to complete them. So I can just right click and it fills that in. Last couple ones, so living room now. And it's probably a good point just to stop and show you a couple of things. We've got one room left to go, but if we click on this living room now, we've got 1.22 kilowatts of heat loss. Just to show you if we change some properties, like let's say now I want to add a chimney with a throat restrictor. That has gone from 1.22 to 2.5 because we've added multiple more air changes per hour. And if we now say that it's without a throat restrictor, you can see how much higher that goes again to 3.78. So quite a vast difference there, and just really highlights how important it is to get the settings correct. All right, and last one here. So we've got the hall, because most of the walls have been done, I can just do one. So left click there, right click here, and it's going to fill all that in for us. If we'd ever made a mistake, like for example, we hadn't gone around this the wall correctly, you can do the edit wall function and put as many points in as you want. So let's say we put a point here, you can then pull that wall, which yeah, we don't want to do, but just to show you, that's how you would do it. And if you want to drag walls, you can, and if you drag one and then another one, yeah, it will snap to where that one is as well. So they will line up for you. So once you've made changes, or if you do need to make changes, it is easy to do that. And like we saw before, it's so fast to draw that sometimes it's just quicker to delete and draw the room again. Alright, but that's all the walls done now. So and that's a good thing with being visual. I could see then that was yellowy orange, so I could see it was an external wall, so I just had to pull it together. Alright, so now let's go put some doors in. So we've got the door drop down here. Can start with a single. So once that, if I try to say put a door here, the brown rectangle, it's not going to let me. It's going to tell me that doors can only be on walls, which makes sense. So now I can, when it intersects with a wall, I can press F to rotate and add these to a wall nicely, just like this. We can make it look more accurate on the size, which we can do in a second. Oops. It's got a couple more to do. And yeah, the direction the doors go in doesn't actually make a difference. It's just a cosmetic thing. I think that's all of them. And the doors, just like the rooms, if we want to click on a door now, we can change the size. So if it is too wide or too thin for what's shown on the drawing, we can change that. You can override materials if they don't all follow the defaults. And we can change temperatures and things like that as well. We also have a bifolding door here, so we can choose that from the drop down. Our default's 1.82, but it's probably about 2.82. So if I just change that in the properties, yeah, it gets much bigger now. And yeah, looks pretty correct. So yeah, we've got that in. And then the last thing we need to do for this is to put windows in. So let's go ahead from the windows. Again, two options, like with the doors. We won't do the Velux window because that's obviously for the roof, but they just drop on like the doors did. And then for the windows, because they're all different lengths, just click where you want to start and then click where you want to end. Keep following that process. So start and finish here. And just point out now on doing this one, you can see the dimensions, so it is very easy for you to be able to, if you hadn't got the PDF to trace over and you just have a measurement from site, very easy for you to yeah, just trace over it. Oh, sorry, just to put it in the right place. Alright, so that is the windows all done now. And just to be super clear, you can edit all of this information once again, but we won't need to. But that is how you do your heat loss calculations. There is one more part to it now, which is the vaulted ceiling, which I'll do. But just to reiterate, I draw all the rooms first, and then in no particular order, I add the windows and I add the doors. And yeah, if you want to review the properties, obviously, would recommend doing that. And the great thing about this is it's visual. So if you have made a mistake or you can't remember if you've done something properly, it's really easy to see. You're not looking through a list of things. It's all just here. And all right, let's do a vaulted ceiling above. So if it's just a flat roof or your insulation is above the flat ceiling, you don't need to do anything. It will recognize this as a roof automatically. But if we wanted to change that, we can choose the roof function here. It will snap to the corners, so it's really easy to trace over. So just click every time you want to put a bend in. And then we have this range of roofs. So you can choose from the menu If you're not sure which each one is, back in the settings before we did have images, which you can also see here, that's a bit small. But let's say we want to have a gable roof, which you can rotate as well if you wanted it like this. And then just to show you the effect this has on the calculations, because there is that whole volume that needs to be, has the earth changes and it has all the extra material. Let's look at this living room. We've got 5.71. If we then change the height of this part to be 1, so much less volume now and much less area. Come back down, we've lost almost a kilowatt. Well, improved it by almost a kilowatt. So once again, just showing you how it's great to have that visual and instant update, because you can see what changes affect your project. All right, but that is everything on the heat loss. So now we're going to move into doing the heating system design. So you want to press design here, and that is going to lock all of that in place now, so you can't edit any of the walls, just because it would probably be an accident and you don't want to move windows and things when you're not trying to. So when you get to the design mode, you also want to click mechanical in the top right here. And now all of the text in the rooms are going to be red. This will turn green, or like yellow and then green, as we approach the 1.63 kilowatts. So it's not always, I suppose it just gives a good visual of if your radiators are big enough for the room. So a very common use case, which we're not going to do today, but just so you can understand what is possible with the software, is that you can model an existing boiler system. So put your boiler in, specify all the temperatures, put all the specific radiators in, and most likely everything will be green, or it should be. Then you can check, as you swap out that gas boiler for a heat pump and you've got lower temperatures, if any of the rooms aren't green, you will know that they're not providing enough heat. And you can also check pipe sizes and things as well. But today we're just doing a new build essentially, and we're just going to go put a heat pump in from the start. But it is a very transparent way that you can show your client if and why the heat pump system needs so many changes, or if it doesn't need any at all. But anyway, let's get on to the heating design now. I always do it in a specific way, which is starting with the equipment. I then draw my main pipes and I add the heat emitters last. Now, definitely understand that's not the way you might draw it if you're doing it like by hand, but it's just the way the software has been designed and will snap together nicely. So you can do it any way that you want. This is just definitely the most efficient way to do it. So that's the way I'm going to do it today. It's not the only way, but definitely would recommend it. All right, so we can drop down the equipment menu here, and we're going to choose the heat pump. So we're not going to go through all of these today, but they are all very similar. So what you learn for the heat pump will work for the gas boiler, for example. And that goes for most things in the software. Like when you're drawing pipes, it doesn't matter if you're drawing a gas pipe, a domestic water pipe. If you know how to draw a pipe and connect something together, that is, you know how to use the software really well at that point. Same like we did the heat loss calculations there. If you're doing the heat gain calculations, you don't do anything different. You just obviously have different parameters to review. But anyway, let's carry on. So choose the heat pump from the drop down. That will follow your cursor, and you want to left click now to stamp it where you want to put it. I'm going to put it here. And just to be clear, I'm not trying to do like the world's best design. I'm just going to really just showing you how it works. So I'm not putting too much thought into where I put things. So yeah, add the heat pump here, and if you click on that, you then get the properties that appear, which are would highly recommend to review. They mostly all have industry defaults in there, but you do just want to check them because maybe you want something a little bit different, and some things are project specific. So some things are just visual, like you can change the shape and the size if you want to. For the energy report, we can change the scope. I'll just leave all that how it is. There's no inlets, but if it was a gas boiler, yeah, you can control how much gas you want to connect, and it will size like gas systems, same for water as well. The outlets we definitely have, so let's say here, we might want the outlet temperature at 45, so we can change that. And we don't want a 10 degree delta T, so we'll then also increase the return up to 40. And there is usually pressure drop through the heat pump, so whatever you add here will get added on to the index circuit. So let's do 0.1 bar. And the last one here is noise. So it will do the MCS noise report for you to see if you need planning permission. So I'm not going to put too much thought into this, but yeah, just choose a few things here, and we'll see that at the end. So that is the heat pump. The other thing we'll add to this design is a cylinder for the domestic hot water. So you can choose one with storage or just a normal cylinder, and you can put a diverter valve on, which we'll do today. Same as we did with the heat pump, drop it on, click on it to see the properties. It's all very similar. A difference here on the specs is it asks for the domestic hot water load. Again, it's going to get used in the energy calculations, so put whatever you want in. SPF for the energy calculations. Then with this one, if we wanted to connect the cold water system, we can connect it here. We're going to ignore it today because we're focusing on heating, but just so you know, you can connect all that up. But we do want to look at the preheat on this one, which is essentially the heating inlets. So what we can do here, I suppose to go through them one by one, we can choose how many kilowatts we want to store in the cylinder. Now most people match what the heating system can do, which I think was about 4.8. So most people size the heat pump on the space heating system and then just put the same kilowatt load in the cylinder. So that's what I'll do here. But of course, put whatever you want in. There is then a volume that gets added onto the heating system volume calc. So it's not the total volume of the cylinder of like the domestic water. It's just for the preheat, how much water is like in the coil. So we'll go with 20 liters, and how much pressure drops through that coil. I'll just leave it like this. And then also for the energy calculation, how often does this get purged, like heat sanitized from Legionella, and what temperature. So you can choose that and it will impact the energy once again. And we don't care about the outlets because that's domestic water, but you can design domestic water in here. We're just not doing it today. So I will leave that. All right, and then the next thing is going to be drawing the system layout. So you can, it is these 4 tools here for drawing pipes. So this one's a riser, so if you're going up to multiple levels, this will connect the pipes between different levels, which we're not going to be using today. Then you've got your return pipe and your feed pipe, so you can draw these individually, but if they follow the same direction like most of them do, we've got this multi-pipe tool which I will use. So you just want to be careful with this because whatever's in the blue circle, like here it's got 2 points, which would be great here, but for example it's got like 5 here, so I don't want to select all those 5. So you just have to be very careful. If you are connecting to 2, you only want those 2, or if you want to connect to 3, it's these 3. But yeah, I'm going to do 2 here. So left click when you want to start, and then left click every time you want to put a bend in it. So I'm just going to keep going here, and the first thing I want to do is connect up to this. So sometimes you can doesn't look like it's going to work, which is probably better for now. So to line things up, sometimes it's easy not to connect. So if you want to finish drawing now, you can press done in the top left or click escape. And it's just better not to connect because it can get pretty messy doing final connections, especially on multi-pipes. Whereas with this, you can now just click on the end and drag it to connect. And you'll see how this will turn solid and colored as it comes across. So you can see the transparent, there's a red circle, it's not connected, and now it is. And it does come with a control valve, which you might not want, so you can always delete them. But every separate circuit does need a lock shield valve, so very important that you have one on. If you delete it by accident, it's very easy to put one back on. So we've got the valves drop down here. A range of valves that I would recommend putting on your design because even isolation valves and things, they will add to pressure loss in the system. And yeah, you want to most likely include it on your index circuit. And I'll just show you how to add one. I'll put a diverter valve on, which is going to go on here. This is where we're going to split off the system. So you can see it's grayed out when it's not connected. And as we intersect, it will turn the color of that system. So if we want it here, left click, do our escape once again, and now the diverter valve is on. And now we're going to carry on with our pipe layout. So multi-pipes, I want to connect to these 2 points. You can't connect to the middle of pipes, by the way, so that's why it picks up these. And I'm just going to draw them here for now. Once again, escape or done once you're done. The last part to the design is just adding the heat emitters now. So we just want to turn all this text green. And there's quite a few ways to do it. So just to make it clear, if I was a user, I'd probably have all of these heat emitters on in the next 1 minute. But because I'm going to show you a few different options, it might take a few minutes. That just shows how fast the software is once you get the hang of it and you've got everything set up how you want it to be. Alright, so let's start in the utility here. We've got 0.4 kilowatts essentially. So the first and the easiest way to add heat of radiators is if we click the radiators here, we get a menu on the left. And there's a few different ways to add them now, so I'm going to go through them one at a time. But starting with the easiest and the fastest is the fixed rating one. So this doesn't care how wide or what type of radiator you're installing. It's just going to put the amount of kilowatts on there. So it's really good if you just want to size your pipes fast and you're not trying to do radiator sizing in the software. So we don't have a 0.39 kilowatt available, but you can add as many as you want, by the way. So you can make a long list here. You could upload your favorite manufacturer like Stelrad, build all their products in and select them. Or you could just add kind of generic ones. Or what you can do here is we can just choose the 0.5 kilowatts and modify it. And I'll just show you a pretty cool feature that it will snap to the walls. So as you move the cursor, it knows you're trying to put it on a wall. So we want to put it on this wall here. So I'll click once, and then it is going to then automatically go to the pipes, and then you can click where you want to connect. So if we want to connect here or somewhere else, you can do that. So let's just go here, click again, and we'll go back to escape. So that has now been added on. The text has gone green because we've got 0.5 kilowatts and we only needed 0.39. So you can actually click on this radiator now. It's got properties like we saw before. So volume for the system volume calcs, pressure loss. So if it's on the index circuit, you can see all of that. But most importantly, what is the kilowatt rating? So if we put in now 0.39, sometimes it rounds up, not the best. So if we just put a 5 in there, there we go, 0.4 now. So turns green when we've got enough. So if you just went around doing that, yeah, very quick. Another way to do it is now if we've got this window might be a meter above the ground. So we want the radiator to be less than that. And we actually care about specifying it. So this time, instead of fixed rating, we'll click specify. We'll choose the radiator style, so I'll just go with an 11. And we'll choose an upper limit. So we don't want the height to be more than 0.6, let's say. Now, when we add this radiator, it's going to figure out the width automatically because we've set one of the dimensions. And you'll notice now how wide that radiator is. If we put it, say, into this room, because the kilowatt load is so much less, it decreases massively. Whereas on this one, it goes really wide. Whereas with this one, it seems about right. And just follow the same process we did before. Just click and yeah, click again. And that is, you see that text that's now gone green. We'll do the same again for the shower. This time we'll limit by width because we want to fit it in that small area. So I'll go 0.3. And yeah, fits nicely. We can even change it a bit, maybe make it a bit wider. And yeah, let's click, we want to connect here, so that's all good. All right, and then the last one I'll just show you is, this is more for if you want to, more for existing systems really, where you want to check everything works properly. So specify again, but instead of upper limit, we go with exact. I'm just going to do a really small one to exaggerate what happens, but let's say we're going with 0.5 by 0.3. So that's what this existing radiator is here. So we've set the specific dimensions that we might have measured on site, or for whatever reason we want that. escape. Now if we look at the text for this room, it's a little bit covered up, but we haven't achieved the 0.46, so the text is still red. So this is how, when you're doing a retrofit, it's a really good way to see what the output is of that room, or what you can actually get with your radiator. So it says 0.1, so if we change it to a type 21, type 22, you can see the numbers going up. So we're getting a bit closer. Let's just change the height to be 700 and see what that does. Okay, now we've got 0.62. So I won't keep changing it too much, but that just goes to show, if you want to use exact dimensions, it is going to look at the desired room temperature, the mean water temperature, the type of the radiator, the dimensions, and give you exact results. Now, just to show you one last scenario with this, let's say the kitchen and the living room are going to have an underfloor heating system. The software doesn't do underfloor heating yet, so it will do in the future, but right now we just go up to the manifold. So let's say between these two rooms, what do we have? We have, it's called about 6.5 kilowatts that we want to add. So if we go to the manifold here, we have some options. So we could do what we did with this utility radiator, just put the 7.5 kilowatt one in and then just edit the properties. But I will just show you how to add one because it's useful. So this is, just to be clear, I'm going to add a manifold, but this is where you would follow this process to add your manufacturer's radiators if you wanted to. So in this nodes section that we've come to, new heating element, so you could put stelrad blah blah blah, put all the information in here at the certain delta T. But we're doing the manifold, so let's go through this one. So a couple of visual things, they don't really affect the calculations, but let's say 600 wide, 250 deep, maybe 500 high. What did we say? I think I said 6.5 kilowatts. But put in whatever you need here, and you can come back and change any of these. For the volume, so based on how many kilowatts, it's going to put in this many liters. So for example, it's going to be 6.5 times 11, which I don't know is about 70 liters, I think. And then what's the pressure drop for your index circuit? I'll do 0.1, and you can say what height you want to connect to this above the floor, which is what we have here. And I can create that. It will get added to this long list that we have, but if you come back to the design now, look down manifolds, here it is, 6.5 kilowatts. And let's, I suppose just to show it snaps to the nearest pipes, but say we want to put it here, just do a left click. And this has turned green, this one hasn't. So it this one, I suppose, is just looking at what's in the room, but you'll just have to know here that that's red, but yes, that does provide plenty for it, which is good. And then we don't need these pipes anymore, so you can click on them in the properties, press delete, or in your keyboard, just press delete. And there we have it. I suppose it's taken us about 35 minutes to this point to do all of the work. I would probably have this done in about 10 minutes if I was just working for a company doing it. So that's how fast you can be once you get the hang of it. So you'll be turning these out really fast. But yeah, that is all the work now. So now it just comes to reviewing the results and looking at what exports we can then provide to our client. So click results here in just a matter of seconds, all been verified by SIBSI. You've got all your pipe sizes and a whole range more information too. So let's go through them bit by bit. I suppose the one that's, or the ones that people most care about is at the heat pump here. So if we hover over the heat pump, we can see the total system volume, 103.5 liters. Total heat load, 7.7 kilowatts. And the index circuit length, just over 26 meters. So you get a lot of good information like that. And if we scroll down on the properties and we come to plant, we can actually turn those on as well. So if you actually want to see the heat load on, you can turn that on. The recirculation pump has been sized here. So we've got the flow rate and the pressure drop. So this we don't have manufacturers built in at the moment. We will soon. But I suppose it just gives you the information that you can check against your preferred manufacturer for now. Then on the pipes, as we hover over this, you can see the box. So it tells you what the flow rate going through it is. Pardon me, it will tell you the velocity, 0.709 meters per second. And it will tell you the pressure drop rate, so 207 pascals per meter. And as you go around the system, we can see, we've got 15 mil pipes around, and it drops to 22 in some places. And you can override pipe diameters if you want to. So if you want to change them, you don't have to take what H2X provides. And I mean, that's pretty much it. If I just scroll up and down on the right here, there's a lot of information. If you want to interrogate the heat loss results, you can say for the door, we can do heat loss through the door. And we scroll on to this one, it's 53 watts. And then I'm sure if we go to this one, it's much more, 185, because of obviously the difference in size. Same for the windows as well. Heat loss through window. We can see they're slightly different based on being different sizes. But all right, we're pretty happy with the results then. And let's say now that we want to move on to exporting this to our client. So move over to the last stage, and there's a few ranges of options here. I'll go through the top three: PDF, heat loss report, bill of materials. So let's start with the PDF. So you can now pick a paper size and a scale that it fits on. I normally like to make it take up most of the page because it looks the clearest. You can change the detail size, so if you want things really big or really small, it does just depend on it's project specific, but you can play around with that. I don't normally include a cover sheet. I think it looks better without it. Any tick boxes you see on the right here will be included. So for example, if you wanted to see the velocity on every pipe, turn that on. But if you didn't want to see that, turn it off. And yeah, just go on to the export then. This will then give you a nice PDF that you can provide to your client or even the guys on site. Good summary of the layout, and in the title block here it would have your logo, and if you fill in this information in the settings, it will include all the project information too. But yeah, so yeah, a really good drawing that you can provide to someone. It shows that you've done all the work. The bill of materials is great too. So this gives a breakdown of everything that you've drawn that has now been sized. So it's just on, just on my other screen. So with this, if we just scroll down to the heating section, all the different pipe sizes, the different quantities, and these are just default rates that we have, but you can put your own rates in so you can get estimated costs. It goes really detailed, so in terms of the T's, side centers, the quantities, the different elbows, all the valves, heat emitter schedules, it's all included. And you can put your own rates in H2X in the back of the Excel sheet, or if you're happy with your current estimating like workflow, you can just take these numbers, which are very valuable, so you don't have to calculate or manually count them all yourself. So that's really useful. And the last one I'll show is the heat loss report. So this is just an overview of all the calculations that have been done in the software. So they keep opening on my other screen. Alright, so with this, again, would have your company logo on it. It would fill in information from the settings, and anything it's not got, you can still add in Word. So with this, it's very hard to match. Everyone likes to provide their information differently, so we give it in a Word document so you can modify things yourself. But anyway, yeah, in the summary here, you can see everything that we're going to go through, or in the content, sorry. But from a high level scroll through, we've got the summary of the results here. So like, what temperatures are we using? What's the total heat loss? What's the worst performing room? You can add in your heat pump model. And then for all the different rooms we've added, a good overview of like the temperatures, the air changes, what rooms surround other rooms, the different dimensions, all the different material areas, and the material, like the U values that have been used as well for everything. And then towards the end, the actual heat loss for every building component. So this makes it very transparent. If something doesn't look right, very easy to see, and you'll notice something's being drawn incorrectly, potentially. You can just go back and change it, which is very easy. You also get a heat emitter summary, so it's going to tell us what we're supplying in each room and what percentage of the demand has been met. So everything should be over 100%. Obviously in the living room, we're sharing the manifold with the kitchen, which is why that's almost 400% and that's 0. But yeah, you can modify that if you wanted to change it in the document too. Here is the noise calculation form. So just based on those, I think 4 entries in the heat pump properties, it's telling you whether you need or whether you're below the permitted development noise limit, which is great to comply with MCS. And then finally, we get the heating or energy usage calculations. So based on the degree days from the settings at the beginning, multiplied by the kilowatt hours, we're getting total kilowatt hours of the year, dividing that by the SCOP to see what's actually being consumed by the heat pump and what's actually being generated, which is very useful for the client. And then for the last one here, it's looking at the domestic hot water. So how much water per year, what's the SPF, and then based on the various temperatures and how often it's doing the Legionella purge, it's telling us how many kilowatt hours per year we need. Once again, what's being supplied and being consumed by the heat pump, and then for the remainder, how much is being supplied for the cylinder or the domestic water, and then how much on the Legionella purge. And that is everything I planned to show today. So the real goal was to teach you how to use it, and even within that time frame of the 45 minutes or so, complete a full, relatively small project. But just to give you an idea of what is possible in the software, I will check if there's any questions shortly. Doesn't look like there's any on YouTube. So yeah, if anyone has any, now's a good time to send them through. And just before I finish, the last couple of things I would say is for anyone that wants to learn this themselves or like follow on from what they've seen today, come to our YouTube channel, search for or click on playlist, and we've got a whole range of videos here that are very bite-sized, easy to follow. And for example, if you want to go back to the building heat loss, we can view that playlist. And just a couple minute videos each tell you how to do all the different parts, which you can follow along. And in addition to that, like we mentioned at the beginning, you can get a 2-week free trial, so you can click try for free here if you want to. Yeah, use it unlimited across your company, see if you like it, and as well as or instead of, you can actually just book a demo with myself or another member of the team, and we can do a one-on-one session with you to get you up to speed with your projects and answer any more questions that you have. But yeah, that is everything from me. It doesn't look like I have any questions, so I'll hold on for a minute or so, but if nothing else comes through, thank you all for your time. Hope you found it useful, and yeah, hopefully speak to you soon. All right, well, I think I will end the webinar. So yeah, once again, thank you. Anyone's got any questions they want to just send through to my email, it is jonathan@h2xengineering.com. Oh yeah, feel free to get in touch there as well. But yeah, thank you once again, and